discussion. So ATM is a link layer technology for an IP network. So this is your standard, let's say, an IP network completely built on top of Ethernet. Okay, so you have all these various Ethernet local area networks, and the Ethernet standard is also called MAC 802. Or 802.3, and everybody has IP addresses. Everybody has Ethernet addresses. The data travels over Ethernet from one point to other inside a LAN, and then uses IP to traverse from router to router. So when you plug in ATM, so then basically in between, Ethernet gets the data across to ATM, and now there is the whole ATM network that carries the data. But you as a user, you won't know that. Okay, so everything is internal. IP converts to ATM, and this is quite common to happen on a long distance link or a link across an ocean and things like that. And on the other end, it's converted back to IP. So a little bit more detail here. This is the whole ATM network. Okay, so there has to be some boundary router that understands this, that this is the router that goes into the ATM world. So here is your regular TCP IP stack, and here is the special router. Router is only talking up to IP. So a packet comes in with Ethernet and physical layer information and an IP address, and this router converts all the data into ATM and puts the ATM level headers in there. Okay, and then it goes inside. Everything goes just with the ATM headers and switches with ATM technology. And when it reaches on the other side, this thing, when the whole data is received, the other router that understands this pushes this back up to IP, and then you're back in IP land. Okay, so you just convert from IP to ATM, go all across the world, and when you reach the end, you get back to IP. So the user never knows that you are using ATM. And obviously, ATM has some advantages as a wide area technology, and that's why you use it. So that's pretty much how ATM is used today. Okay. Okay, that's basically the point I wanted to get across, so you don't have to worry about any of the details here. Okay. Any questions on ATM? Okay, so the second mini topic left in this is MPLS, which stands for multi-protocol label switching, and routers that employ that. A short name for that is also label routers. Okay, so so the idea here is, initially at least, is that IP has an overhead that ATM, for example, does not, which is that IP address is 32 bits, and every time you go to a router, all 32 bits have to be matched against this big table, which has to respond to all possible addresses, and it takes a lot of time to process that information, figure out, compare and figure out where each packet needs to go. So let's try to speed this up. Okay, and the way to speed it up is that so this is an MPLS structure, and you still have the IP header, but in addition, you have a label. Okay, so a packet, in addition to its IP address that it's going to do, has A, B, C in the label field. And the router can be smart enough and just look at this field and say, I know any packet that's A goes to the left, so the router can decide all the A's go here and all the B's go here. And you can build a scheme where you just have to look at this label, not the real destination address, to to decide where to go. Of course, first time you have to configure all this. You have to know what A means and where it should go. But once you figure it out, you don't have to do the whole IP address match. You just put A's and B's. Doesn't matter where the packet came from. Doesn't matter where it needs to go. If it's A, it goes left. B, it goes right. Okay. So it's a trick to try to speed things up, or that's what the initial idea was. Okay. So yeah, so it's a label switched router. So forward packets based only on the label. Don't worry about IP address. So that's the whole idea. So of course you have to set up all this, and this the RSVP is one of the signaling protocols where you would figure out what label to put and what that means. Okay. One of the key things here is that they did not want to make a separate protocol. That's why the whole IP address is there, that at some point in time you will reach a non-labeled router and you'll have to use the IP address to move forward. Okay. So just to make it clear, let's see, look for an interesting, so this particular router, it says that so the destination is A. In this case also the destination is A, but the label in one case is 10 and the label in the other case is 8. Okay. And it says like if you come from 10, then you go this way. If your label is 10, and if your label is 8, you go this way. It doesn't matter that your final destination is A. Okay. So at least this is a capability that is already there. And but why would you want to do that? There can be only one optimal route to A. Why would you want to send some packets through this interface and some packets on this interface when they have the same destination? I'm sorry? You want to overrule? You won't overload one side. So one thought is that you don't want to send everything one way. It might be too much, so you want to distribute, load balance, and yes, that is a possibility. However, for that, you didn't really need all this label information. You could have just decided, just at the router, that if I get traffic on this side, I'll try to keep the two routes busy. But that's true. That's one way you could use it. Okay. Any other reasons you want to send traffic? So this is also called source routing, which you'll hear this buzzword a lot. That normally routing is based on destination, right? Where you need to go, you're routed. Here, you're not basing completely on destination. You're also basing it on where you came from. Okay. So why would you want to make different decisions based on where the traffic is coming from? So what you're doing is also called traffic differentiation. You know, traffic from University of Houston goes one route, and let's say traffic from Halliburton goes a different route. Why would you want to do that? Apartheid? What? Right. Right. Well, basically, you can differentiate traffic, and you say, well, maybe somebody pays you more money, right? So you heard of VPN, virtual private network. Okay. What is? Anybody knows what is VPN? Log into it. So virtual private network is where you pay a lot of money to some backbone provider, and they say, you know, between here and let's say Zurich, you're going to get guaranteed 10 megabits per second. Doesn't matter that all other users are getting 5, 6 kilobits